Hey everyone, Mr. Murray here, and we're going to learn today how to solve radical equations. We might have done one or two in the last video, but we mostly focused on rational exponents, like this guy right there. So now we're going to deal with radicals instead of these. How do you solve radical equations? So here's what you know so far. I have this list for you on your sheet. You should look at that. And today we're going to learn how to do this. Sorry, okay, this guy right here. So let's check out the rule that we're going to use to make this happen. You know, or if you don't, you're learning now that if you square a radical, it's like saying multiply it by itself. And what we would get is outside numbers multiplied by outside numbers, inside by inside. And here you see we only had insides, and it was 9 times 9, 81. Now the square root of 81 is 9. And that's the entire key right there. If you square a radical, basically this 9 just pops out. Even when it's more complicated like this. So you have 3x plus 5 under a radical. If you just come up and square that, you might as well just say, okay, 3x plus 5 falls out. So that's what this page is demonstrating to you. Just the whole idea of if you square a square root, you basically get rid of the square root. Okay, so when we're doing equations, just remember, we're going to do both sides. Because after all, equations have to stay fair and balanced. Okay, so this is a side note that, since we were just doing this yesterday, if you wanted to solve radical equations using exponents, there's no reason you couldn't. You could take that square root of x and change that to x to the 1/2 using the ins and the outs, like we learned. And then how do you get rid of that rational exponent? You multiply it by its reciprocal, or you use the power rule to turn that into a 1. So you end up with this being x to the first power, and this guy is 9 squared. And that's how we got x equal to 81. Okay, but for this video, we'll mostly be focusing on this idea, that we'll just square both sides, get rid of the radicals. Okay, so here are the steps that we're going to want to remember. First of all, isolate the radical. Get it all by itself before you start squaring both sides of an equation. We don't want anything next to the radical, just radical. Then we square both sides. Now, whatever variable you're working with, usually x, solve for that. And then, of course, check your answer, because in this lesson, we will be rejecting some answers, and some answers won't work, and some questions will have no solution. And this is these are a couple pro tips right here. Even if you have a radical on both sides, which you'll see, it kind of freaks you out when you first see it, you still just square both sides and both radicals disappear. And please, finally, this I still see. Since we're going to be squaring both sides, this will happen often. You'll be squaring a binomial. So please remember, x minus 5, just for example, squared is not equal to x squared plus 25. It's far more complicated than that, wouldn't you say? It looks like this. So then you FOIL. That's what it looks like. Keep that in mind. Okay, so let's work some examples. This guy right here. I have 3 times a radical equals 9. That's my fire alarm, sorry. So let's divide both sides by 3 to try to get this radical all by itself. So I have square root of 2n minus 1 equals 3. I'm ready to go. I've isolated my radical. Let me square it, and let me square the other side. And like I said, whatever's in the radical just pops right out, and this turns out to be 9. Let's solve for n. So 2n is equal to 10, and n therefore is equal to 5. Let's do a check. So our check is always in the original equation, right? So here's my check. 3 times square root of 2 times 5 minus 1, does that equal 9? So this is 3 times the square root of 9. That would be 3 times 3. Oops, sorry. And sure enough, that's correct. 9 equals 9. So we accept the solution, n equals 5. Let's try the next one. Okay, here's that thing. Each one of these questions you should go through because it has something unique. We're not just going to blast through a bunch of sample problems. Hopefully each one of these has something new to it. And in this case, it's the radical equals a radical. So don't stress. If you have a radical equals a radical and you square both sides, everything that's under the radicals comes out. And now you'll agree this is just a simple algebra problem. So let's solve for x. I think I'll take away 6x's. I always try to keep my x's positive. So this leaves me with a positive 1x. That's equal to 1. Let's do a check. Maybe we'll go blue. Okay. Okay, here's the check. Original question only. So square root of 7 times 1. Are you equal to the square root of 6 times 1 plus 1? So that looks like square root 7 equals square root 7. You can use your calculator to get the decimal, equivalence of those two, but you can see right there they are equal. So we will accept 1 as our answer to this question. I hope you found those too easy. That's generally the idea of what we're doing. Now we'll just get a little nutty. Okay. Look at this guy. If you can't get rid of the hanger-on, that's okay. So I've got this 2 I'd love to get rid of. But if I divide it from this side and this side, what's going to happen? That looks weird, right? Same problem. I've got this hanger-oner here. So if you do, it's okay. Just follow the rules of multiplying radicals. For example, when we solve this, I'm going to say square both sides. So if I square this side of the equation and this side of the equation, starting with the right, that's the easiest, I've got 2r plus 220. If you square the left, remember that's like multiplying this twice, right? Okay. We would multiply outsides to outsides, which would give us 4. Insides to insides, that's when the radical goes away. Whoa, what was that? Sorry. Let me write this neater. So 4 times 3r plus 30 equals 2r plus 220. Okay, so that's it. Solve for r. There'll be some distributing to do, that's for sure, but nothing crazy. So this turns out to be 12r plus 120, and that's equal to 2r plus 220. So I'm thinking, keeping the r's positive. Let me take away 2 r's here, leaving me with 10r on the left side. So let me move this 120 over to the other side, and you'll see the example works out very nicely. 10r equals 100, divide by 10, r equals 10. Now, that may or may not be true, so we go to the original question and we plug in 10 for r. Okay. Now, is this true? So 2 times the square root of 30 plus 30, which is 60, are you equal to the square root of 20 plus 220, which is 240? Now, again, use your calculator if you'd like. But maybe you see that this is good house, bad house on a 240, and if you simplified that radical, you would get 2 radical 60. But if you'd like, you can always go to the calculator later and just confirm the decimal equivalents, But you can definitely see here that they're the same. Okay, so we like this. R equals 10 is a good answer. But here's the rejection part. So there will be a time when you solve radical equations where you're going to reject one or both solutions or, the only solution, whatever the case may be. So let's take a look at this question. I have a radical and a binomial. The radical's alone, so we're happy. We're going to square both sides. And this is that pro tip from before, right? This is not equal to b squared plus 25. What this is equal to is b squared minus 10b plus 25. And when you square a radical, everything just falls out. Cool. So I've got this squared. So let's set it equal to 0 and factor, right? That's what we do. So over here, I'll do it in one step just to save some time. I'll subtract 2b and 5 from both sides. That gives me my 0. And over here, hopefully something I can factor very easily. Let's take a look. Yes. This can be b minus 10 minus 2, right? I'm just looking for what adds up to negative 12 and multiplies to positive 20. That was an old unit on factoring we did, and it's coming back to haunt you. Okay, so T-chart, b is equal to 10, and b is equal to 2. So let's see if all of these work. Our potential solutions are 10 and 2, like your driving position in driver's ed. You'll hear that later in life and laugh. 10 and 2. Okay, let's plug in the 10. So 10 minus 5, this is our check. 10 minus 5, are you equal to the square root of, let's see, 2 times 10 plus 5. Okay, this is 5. Are you equal to 25 square root? Yes, absolutely. Cool. Okay, first one's good. Second one, 2. Okay, 2 minus 5. Are you equal to the square root of 2 times 2 plus 5? Negative 3, are you equal to the square root of 9? Oh, that is close, but it doesn't work. Negative 3 is not equal to positive 3. Okay, so we reject this. We reject this. And if you want to be all fancy schmancy, why don't you write that? Reject. So our solution is only the 10. Next guy. Imaginary numbers. So remember, squaring both sides here will give you 4i squared. And if you remember your i's, you'll be fine. Remember that I squared equals negative 1. So with that in mind, this becomes a very simple problem. This is 4 times negative 1. So negative 4. Cool. Okay, so let's solve for p. 2 ways to do it. Go to 0 in GCF, or maybe I'll take away 4 from this side. Negative 8p is equal to negative 8. Divide both sides by negative 8. P is equal to 1, potentially. So we go check it out, and what do we get? Square root of 4 minus 8 times 1. Does that equal 2i? So 4 minus 8. Okay, so that's negative 4. Are you equal to 2i? Oh, absolutely. Remember, this is the thing, right? You have a negative under a radical. you pop an I out, and then evaluate the radical. So what's the square root of 4? That's a 2. Don't forget your I, and look at that, it's beautiful. So it's possible to sometimes put imaginary numbers into these equations if it's something as simple as just squaring it. No problem. Okay, this is the nobody's home example. Let's see what happens here. Square both sides. R squared is equal to -1 minus 2r. Again, I see a squared, right? So let's set this equal to 0 and factor. I'll do that again in one step. I'll just add 1, and I'll add 2r to both sides. So I'm going to move over a little for room. That leaves me a 0 on the right, and on the left I'll have my r squared plus 2r and a plus 1. Okay, can I factor this? What adds up to 2 multiplies to 1. Yeah, those will be both 1s. Okay, oh, this is a perfect square trinomial, like when we complete the square. Very cool. Okay, T-chart, you'll see that there's only one answer, -1. So we check, and let's see what happens. -1 equal to the square root of -1 minus 2 times -1. So if we clean this up a little bit, under the radical is going to be -1 plus 2. And to finish this off, see, it's close again, but it's not going to work. -1 is not equal to 1. So you reject, and look, we rejected both because they were the same. But there's nothing left. So that means this is one of those sorry can't solve, so you might want to do this, empty set. Or you can just write no solution. Oops. Sorry, that looks like, yeah, that looks like solution. Welcome to New Jersey. Okay, last one. This one's nuts. Okay, so you can't do this. Watch. Watch what happens. 6x plus 2 equals, let's be professionals here, we'll do this right away, x squared, 4x, and a 4. Okay. Set it to 0 and factor. Cool. Now here's the problem. Not that this is a problem, because you could get good answers this way, but the first problem I'm looking at is this guy. I can't factor that. You know, there's nothing that adds up to -2 that multiplies to +2, so this isn't looking good. So how can you solve a quadratic equation when all of your factoring techniques are exhausted? You can go straight to the quadratic formula. So you get your ABC, which is 1, -2, and 2. So you might want to use this, you know, in our classwork. We might have examples that need the quadratic formula. It's no big deal. It just takes a little more time. So x equals -b. So negative of a -2, plus or minus the square root of b squared minus 4ac. Cool. All over 2a, which is 2. So doing some simplifying, this is 2 plus or minus 4 minus 8 all over 2. X equals 2 plus or minus -4 all over 2. Oh, there's that -4 again, right? We know that that's 2i. Cool. So x equals 2 plus or minus 2i all over 2. I know we always say you cannot break up a marriage like this because they're married. However, if you can break them up evenly, you're good to go. So I can divide each of these terms by 2, which is actually kind of cool because it gets rid of the denominator. And you're just left with 1 plus or minus I. If you want to break that out, you have 1 plus I and 1 minus I. But these suckers right here are what we call, and what you know, are complex numbers. And that's not good here. So we won't be working with any solutions to radical equations that are complex numbers. We will be looking at the domain to be all reals, which is that big fancy double R like that. Okay, so just real numbers. Complex numbers are a little bit crazy and a little bit sane, right? You've got your A and your BI. So we only want the A's. That's the lesson. I hope you enjoyed it, and if you have any questions, please come to Extra Help. Hope you have a wonderful time on the classwork. I wish you luck. Take care.